Hello students, today we will talk about electric dipole. We will see what is electric dipole. We will see how it differs from an atom. We will also see if electric dipole is having electric field in its surrounding, and we will also compare electric field of dipole at different points around the dipole, whether field is more, field is less, how it depends on the point or distance. Okay, so let us start. But before we start with electric dipole, let us understand certain things about an atom. We know that in atom we have positive charge in the nucleus and negatively charged electrons moving around the nucleus in orbit. But the atom is having both positive and negative charges in it. Now what if we take some charge q and place it at some distance r from the atom? Would there be any attractive or repulsive force on our charge q? Should there be any force on this charge q? Well, for that, first we'll have to see how far the positive charge is. Now, as we can see in the diagram, the r is the distance of positive charge from our point charge q. How far is the negative charge from q? Well, as electrons are moving in the orbit, the effective distance of negative charge from q is also considered to be r. Hence, we can say that for an atom, the center of positive charge is nucleus. And where is negative charge? Now, center of negative charge is also nucleus because electrons are moving around the nucleus. Thus, for q, when you consider force due to positive charge, the distance is r. When you consider force due to negative charge, the distance is also r. So distance of positive and negative charges both are same for our charge q, and hence whatever is the force of positive charge on q, same is the force of negative charge on q, but in opposite direction. Hence resultant force on q has to be 0. Thus we can say that for an atom the net charge is 0, but not only that, net charge is 0, but its electric field is also 0. Well, this is not the case for so many molecules. There are molecules in nature for which this fact, where electric field is 0, is not holding true. And what if the electric field is not 0, and why it should not be 0? Well, we'll see that next. Consider a water molecule. We know that in one H2O molecule we have two tiny hydrogen atoms attached to one very big oxygen atom. And though electrically H2O molecule is neutral, you don't have net charge with H2O molecule, but because of the size difference between the atoms, constituent atoms, the center of negative charge and center of positive charge for this molecule are not at same point. Center of negative charge and center of positive charge, they are not coinciding, they are separated by some distance. And so this is not very similar to atom. And we have one more such example. Consider HCl molecule. Here also you have chlorine atom very big as compared to the other one, hydrogen atom. And here again you have center of positive charge and center of negative charge separated. Electrically this molecule is again neutral. You don't have net charge, but the centers are also not coinciding. Such molecules are called polar molecules, where you don't have center of positive charge and center of negative charge coinciding, where you have center of negative charge and positive charge separated. And you can also say that these molecules are forming electric dipole. They are also called electric dipole. Normally, electric dipole is represented by two equal and opposite charges separated by some distance. And any electric dipole is characterized by its property called dipole moment. The expression for dipole moment is product of charge into separation between the two. The unit of dipole moment is coulomb into meter, and it is vector quantity. Its direction is considered from negative charge to positive charge. Let us try to understand the effect of atom and effect of dipole on any charge placed around them. So if we consider a charge q at distance r, we know that for atom, center of positive charge and center of negative charge both are coinciding. They are at the same point in the nucleus. So if we consider the force on q due to the we know that it will be away from the atom. And what is the direction of negative charge of the atom on q? The negative charge will exert force towards the atom. If it is F negative, it should be like this. But the two forces will be same in magnitude. Why same in magnitude? Because they are at the same distance. The two charges of atom are at same distance from q. Hence, the forces are opposite in nature and equal in magnitude. So what is the resultant force on q? It will be 0. It has to be 0. But if we consider a dipole, let the charge on dipole be minus q and plus q, two equal and opposite charges, and let the separation between the two charges be 2a. So we have this dipole, and now let us place our charge q at distance r from the center of the dipole. How the situation differs here? Here, as we can see, the distance of positive charge and negative charge from our charge q, the distances are not same. So let the distance of positive charge from q be r positive, and let the distance of negative charge from our q be r negative. So if we denote force on q due to positive charge of the dipole by F positive, it should be like this, away from the dipole. And what the negative charge of dipole will do? It will try to pull q towards it, and let the force be F minus, F negative. So we have again two forces acting on our charge q. But the difference is these two forces are not exactly opposite in the direction. Moreover, when you consider this r positive and r negative distances, as they are not same, the forces experienced by q will also not be same in magnitude. Hence, our charge q will experience some non-zero resultant force, which is not the case of atom. In case of atom, q experiences zero resultant force, but when placed around dipole, it will experience some resultant force. And hence, we can say that for any dipole, there is electric field around the dipole, which we realize when we place some charge in its vicinity. Let us now summarize our comparison of atom and electric dipole. Now we know that for an atom, the net charge is 0. Whatever amount of proton you have, we have equal number of electrons. So what is the net charge of atom? 0. It is electrically neutral. What is electric dipole? Electric dipole is a system of two equal and opposite charges separated by some distance. So what is the total charge of electric dipole? What is the net charge of electric dipole? Now net charge of electric dipole is also 0. But when you place some point charge q near the atom, it doesn't experience any force because electric field of atom is 0. What happens when you place point charge q close to dipole? The resultant field is not 0 because electric field of a dipole is not 0.